Hi, welcome to pibyme Maths. This is Baiju Vasudevan. Here we are solving May-June 2023 for the Pure Math 1 paper. In the previous video, we have covered question number 1 to 5. Let's look at question number 6 now. You have two complex numbers, three of them, z1, z2, z3. Determine the exact value of modulus of z1 plus z2. So modulus of z1 plus z2 is equal to modulus of 3 plus 2i plus 2 plus 3i. So it's going to be 5 plus 5i. How do we find the modulus? Square root of x square plus y square. Square root of 50, which is 5 root. That's all. Just a 2-mark question. Part B. Given that w is this, determine w in terms of a and b. So w is equal to z2 times z3. z2, right? z2 is 2 plus 3i. 2 plus 3i times a plus bi divided by z1 is 3 plus 2i. And then we multiply the conjugate of the denominator, 3 minus 2i. That's how we write the complex number in this form. Okay, first I'm going to multiply these two first. So it's up to you. You can multiply these two and then times a plus b. You'll get the same answer anyway. So when I'm going to multiply 2a plus 2bi, 3ai minus 3b. When you multiply these two, it's 3bi square. I square is minus 1. Times 3 minus 2i divided by the denominator becomes a plus b times a minus b, which is a square minus b square, 4i square. And then I'm going to multiply everything by 3 and then by minus 2i. When I multiply everything by 3, it's going to be 6a plus 6bi plus 9ai minus 9b. Now I'm going to multiply everything by minus 2i now. Minus 4ai minus 4bi square is negative 1, so plus 4b, and then minus 6ai square, I square is negative 1, so plus 6a plus 6bi, everything divided by 4i square is positive 4, it's 13. That's all. Now we just need to simplify the like terms, all the real parts. Simplify the real parts. We have 6a 12a, so we have 12a, and then minus 9b plus 4b is minus 5b. That's a real part, divided by 13 plus I times, this is the real part, plus I times, we have 6b 12b, and then 9a minus 4a is plus 5a divided by 13. That's the final answer. They want us to write it in this form, x plus iy, right? This is x plus iy. So that's all. It's a 4-mark question. Part C. Given also that w is this, determine the value of a and b. It's just a simple one. Equate the real part of this to the real part of this. Both has 13 in the denominator, so leave it. Just equate the numerator. 12a minus 5b. 12a minus 5b is equal to 4. And then you do the same thing for imaginary part. Here the imaginary part is 5a plus 12b is 58. Just solving simultaneous equations. So multiply the first equation by 5, second equation by 12. 5 times 12, 60a, this also 60a, minus 25b. Okay, it's up to you how you want to solve it. Okay, anyway, 25b plus 144b is 58 times 12. 696. I'm going to get rid of the a by subtracting them. So I'm going to subtract this way. I change the sign of this. So a will be cancelled. 169b is equal to 676. 676 divided by 169. b is equal to 4. Sub in into any one of the equation. I'm going to sub in into the first equation. 12a minus 5b is equal to 4. 12a is 24. A is equal to 2. That's all. Just a 2 mark question. Part D. Determine the argument of W. We know W is equal to 4 over 13 plus 58 over 13i. So argument of W, definitely both numbers are positive. So in the argon diagram, the point will be here in the first quadrant. So the argument will be just theta, which is just tan inverse of y over x. You need to use your calculator in radian, get the answer to 4 significant figure. So in radian, tan inverse of 13 will be cancelled. 58 divided by 4. They want the answer to 4 significant figure, 1.502. 1.502 radians. That's the answer. Question number 7. f of x is given as x power 3 over 2 plus x minus 3. Show that it has a root in the interval 1, 2. So let's find the value of f of 1 and f of 2. f of 1 is 1 power 3 over 2 plus 1 minus 3. 2 power 3 over 2 plus 2 minus 3. This is definitely 2 minus 3 is negative 1 is less than 0. Now f of 2 is 2 power 3 over 2 plus 2 minus 3. You get a positive number, 1.828. We are not interested in the value actually. It's positive. There is a change of sign. You need to write there is a change of sign. And write this actually, f of x is continuous. Therefore, what does that mean? If the sign changes from negative to positive or positive to negative, definitely when you sketch the graph, the curve is gonna cross x-axis this way or this way. There is a crossing at the x-axis. The crossing is the root, right? So therefore, f of x equals 0 has a root alpha. You just write this sentence in the interval 1, 2. That's it. Part B. Starting with interval 1, 2, use interval bisection twice to show that alpha lies in 1.25 and 1.5. Okay. I have copied these two values from the previous part because we know the root lies between 1 and 2. 1 and 2. To apply the interval bisection method, you take the midpoint of 1 and 2 is 1.5. Let's find the value of the function at 1.5. You can draw the table and do that also, or you can do it this way also. F of 1.5 now. F of 1.5 is going to be x power 3 over 2 plus x minus 3, which is a positive number. 0.337 is greater than 0. So this is also positive, this is also positive, this is negative. That tells us the root lies between these two. Because when there is a root between the 2 points, the sign changes, right? So we ignore this, we take these two now. So we ignore this, we take these two. And then again, take the midpoint of these two. The midpoint of these two is 1.25. Find the value of the function f of 1.25 now, which is 1.25 to the power 3 over 2 plus x 1.25 minus 3. You get a negative number, 3524, negative 0.3524, etc. That means this is also negative, so we ignore this. Do not strike out this in the exam paper, please. I'm just trying to explain this. So definitely the root lies between these two. So we need to write, therefore the root, you need to mention this is less than 0. Root lies in the interval 1.25, 1.5. You need to write this interval, limit actually. You need to put the smaller number, comma, the bigger number. That's all. It's a 3-mark question. Part C, I determine f dash of x. We know f of x is x power 3 over 2 plus x minus 3. So f dash of x is 3 over 2, x power 3 over 2 minus 1, which is 1 over 2. X becomes 1, minus 3 becomes 0. That's all. Double now. Use your first approximation as 1.375 for alpha. Apply Newton-Raphson process once to determine the second approximation. Give your answer to 3 decimal place. If you look at the data booklet, the Newton approximation, the rule is given. xn plus 1 is xn minus f of xn divided by f dash of xn. That's a rule. Okay. So the first approximation, when you sub in the point, you don't need to worry about whether x1 or x2, and I'll just write it as alpha is equal to xn. This is the first approximation, 1.375 minus, into the original function you replace x by 1.375. So 1.375 to the power 3 over 2 plus x is 1.375 minus 3, and then sub in the x in here, f dash of xn, 3 over 2 times 1.375 to the power half plus 1. So just calculate this value. That's all. Round it to 3 significant figure. So I'm going to do everything in one shot actually. 1.375 minus, on top I have 1.375 to the power 3 over 2, which is 1.5, plus 1.375 minus 3 divided by 3 over 2, which is 1.5, times 1.375 to the power half, 0.5, plus 1. They want the answer to 3 decimal place, so 379380, 1.380. That's all. Question D. Use linear interpolation once in this interval to obtain a different approximation for alpha. Give your answer to 3 decimal place. First of all, you need the value of f of 1.25 and f of 1.5. Which is 1.25 power 3 over 2 plus 1 plus x minus 3. You need to sub in the value into the original function. 1.5 minus 3. Let's get these values first. 1.25 to the power 3 over 2 plus 1.25 minus 3. So when you get this value, immediately store the value as a 3524 minus 0.3524 dot. If you want, use your pencil to write a little reference here, a. so you won't mix up the values. Now let's find f of 1.5. 1.5 to the power 3 over 2 plus x, which is 1.5 minus 3. Again, I'm going to store the value as b now. 337, 0.337 dot dot dot, just put a little reference b here. Now we are going to apply the linear interpolation. So let's say these two values, I'm going to draw a line. Let's say 1.25 is here, 1.5 is here. The function value f of 1.25 is a negative number, so it should be below, right, on the y-axis. Should be below. This is f of 1.25, but this length is, we need to take a positive value, so we are going to multiply this by a negative sign. So I'm going to put it as negative f of 1.25. I hope you understand this. And then f of 1.5 is a positive value, so I draw another line here. This is f of 1.5. This length of the line is f of 1.5. Let's connect these two now. And this is alpha. Okay. Now the linear interpolation in this case, it's same like similar triangles. So this length divided by this length. Let's say alpha is here. Alpha minus 1.25 divided by 1.5 minus alpha. That's how you find the length, right? On the x-axis, bigger number minus the smaller number will be same as this length divided by this length. That means minus f of 1.25 divided by positive f of 1.5. You don't have to mention the value, actually you can just write it this way. We'll sub in the value at the end, and you need to cross multiply, make alpha as a subject. So when you cross multiply, alpha times f of 1.5 minus 1.25 times f of 1.5 is same as minus 1.5 f of 1.25 plus alpha times f of 1.25. I hope you understand this step. You cross multiply them and then make alpha as a subject. Okay, now I'm going to push this term here because these two terms involving alpha, if you take alpha as a common factor, f of 1.5 minus f of 1.25, alpha as a common factor, is equal to, push this term here, 1.25 f of 1.5 minus 1.5 f of 1.25. Now you write alpha is equal to 1.25. Instead of f of 1.5, we can write the value, which is 0.33 times 0.337 dot 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 minus 1.5 times f of 1.5, which is negative this value 3524, negative 0.3524 divided by 0.337 dot 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 minus of f of 1.25. When you bring this here, it becomes the denominator, right? 3524. But when you put it in your calculator, it's very easy because we store the values a and b. Which value is a? The negative value is a. So we are going to use a here, b here, b here. So it's very easy to calculate. 1.25 times b minus 1.5 times a over b minus a. That's all. That's the answer. 1.377 dot dot dot. But read the question. They want the answer to be rounded to 3 decimal place. So you can write therefore alpha is equal to 1.37. The next digit is 7 also, so 8. That's all. That's how you apply the linear interpolation method. Let's move on to question number 8 now. The point P lies on the parabola with this equation. Show that this point Q also lies there. Replace the x and y coordinate, x and y by x and y coordinate of the point. So minus 4 over P whole square is equal to, or you can just first write LHS is y square is equal to minus 4 over P whole square is 16 over P square. RHS, right hand side, left hand side and right hand side of the equation. 8x is equal to 8 times 2 over P square is equal to 16 over P square. LHS is equal to RHS. Therefore, Q of 2 over P square comma minus over P lies on the parabola. That's all, just a one more question. Part B now. Show that the chord PQ passes through the focus of the parabola. We have a point P given here, 2P square comma 4P, and we have another point Q which is 2 over P square comma minus 4P. We need to find the equation of this chord PQ, and we need to prove that it passes through the focus of the parabola. We have the equation of the parabola y square is equal to 8x. If the equation is y square is equal to 4ax, the focus of the parabola is a, 0. So here 4a is equal to 8, a is equal to 2, so that the focus is 2, 0. So we need to find the equation of the line PQ and make sure we need to prove that the point lies on the line. So that's what we are going to do. First, let's find the slope of the PQ. So y2 minus y1, 4p plus 4 over p divided by x2 minus x1, 2p square minus 2 over p square. So when you simplify it, it's going to be 4p square plus 4 over p if you combine it to a single fraction. 2p power 4 minus 2 over p square. There are two fractions. This p will come down, this p square will go up, so you can cancel this. And this p square will go up, p will go up. So we'll get p times 4p square plus 4 divided by 2p power 4 minus 2. We can even further simplify this. Take 4 as a common factor. 4p times p square plus 1. If you take 2 as a common factor, here, you get 2 times p power 4 minus 1. You can write it as 2 times p square plus 1 times p square minus 1. A square plus b, a plus b times a minus b is a square minus b square, right? And you can cancel this too. So the slope is basically 2p over p square minus 1. That's the slope. Now we use any one of the point and the slope to write the equation. So I'm going to write the equation y minus, I'm going to take it as x1 y1, y minus y1 is equal to this times x minus x1. That's the equation of the chord PQ, and you don't have to expand it because we don't need to find the equation. We just need to make sure the point 2, 0 lies on this line. Okay, so you write focus of y square is equal to 8x is 2, 0. So we are going to sub in the points now to prove that both sides are equal. So I'm going to take left hand side. So x is equal to 2, y is equal to 0. You can just sub in on both sides actually. So minus 4p is equal to 2p over p square minus 1. replace x by 2, 2 minus 2p square, which is 2p over p square minus 1. If you take minus 2 as a common factor, you'll get p square minus 1 can be cancelled as equal to minus p. Therefore, the chord, because both sides are minus p, that means the point satisfies the equation. The chord PQ passes through the focus of y square is equal to 8x. That's all. Part C. Wow, it's an 8-mark question actually. The tangent to parabola at the point P. You know, the point P is 2p square comma 4p, 2p square comma 4p, and the point Q is 2 over p square comma minus 4 over p. The tangent to the parabola at P and the tangent to the parabola at Q meet at the point R. Find R. So we need the equation of these two tangents, right? So to find the equation, that's why the question got 8 marks actually. I'm going to take the equation of the parabola. Y square is equal to 8x, y is equal to square root of 8, which is 2 root 2, square root of x. So that I can find the slope by differentiating it. 2 root 2 times half x power half minus 1. So 2 will be cancelled. You will get root of 2 divided by square root of x. Now slope of the tangent at the point P is equal to, sub in the x coordinate here, root 2 divided by root of 2p square. You will get just 1 over p. Root 2 will be cancelled. Square root of p square is just p, right? This is the slope of the tangent at point P. At point Q, you need to remember, if let's say this is the parabola, even though we use this equation y square is equal to 8x, this will give you, in functions it will give you only the positive square root. So if in any case a point has a negative y coordinate, because the line PQ passes through the focus, so we are going to assume that P is here, Q is here, right? Because both points are positive. P is here, Q is here. Q lies in here. So when you take this piece, you have to take it as a negative square root. When you find the square root here, you need to be very careful about this, because you see, if you sub in this x coordinate in here, it's going to be y square is equal to 8 times 2 over p square, which is 4 over p square. When you take square root, you are taking only the negative square root, right? So it is 16 over p square. The negative square root of 16 over p square, that's why you are getting negative 4 over p. So when you take y here, you should have taken it as negative square root. So y is negative 2 root 2 x power half. So dy over dx is going to be negative root 2 over root x. It's the same thing, but you have a negative sign. Now the slope of the tangent at the point Q is root 2 divided by square root of x. Square root of x. So square root 2 will be cancelled. Square root of p square is p. It will go up minus p. So we got the slopes already. Let's find the equations separately and solve the simultaneous equations. Okay, the first equation is going to be y minus y1 is equal to slope times x minus x1 using the point P. And when you use the point Q, it's y minus y1, which is y plus this, is slope times x minus x1. We have two equations now. We need to solve the simultaneous equations and find the value of x and y. So bring the 4p here, 4 over p here, and equate them. So you will get 1 over p or x over p minus, when you open the bracket, 2p. Okay, bring the 4p also here, plus 4p. That's y, right, which is equal to, here what is y? When you open the bracket, minus px plus 2 over p minus 4 over p. When you bring this here, that's y. So you equate the y's. So bring it here. So you will get 1 over p plus p times x is equal to, this is basically 2p goes to the other side, minus 2p plus 2 over p minus 4 over p. And we need to simplify this. So let me just simplify this two first. It's basically minus 2, the denominator is the same, so 2 minus 4 is minus 2, right? Minus 2 over p. So if you take minus 2 as a common factor, you will get 1 over p plus p, which can be cancelled. Therefore x is equal to minus 2. And then we need to sub in x is equal to minus 2 into any one of the equation to find y. They want us to find, what the question says, they want us to find both x and y, right? The coordinates of r. Yes, okay. So I'm going to sub in x is equal to 2 here. Therefore y is equal to 4p comes here, open the bracket, 1 over px, which is minus 2 over p. When you multiply these two, it's just minus 2p plus 4p. It's minus 2 over p plus 2p. That's the y coordinate. So you need to write finally, question says r, right? So you can write therefore r, write the point r, minus 2 comma 2p minus 2 over p. That's the x and y coordinate of the point r. That's all. The last question now. Prove by induction that for all n belongs to integers but n is greater than or equal to 2. That's very important. Okay. So you don't sub in n is equal to 1. Like usually we sub in n is equal to 1, right? Prove that this expression is divisible by 18. So for n is equal to 2, that's f of, first step you can write it as f of n. F of n is 4 power n plus 6n minus 10. So f of 2 is 4 square, 6 times 2 minus 10. 12 minus 10 is 2. 16 plus 2 is 18. Therefore it's true for n is equal to 2 because 18 is divisible by 18. And the next step you need to write, assume that, we need to assume that for n is equal to k, the statement is true. F of k is equal to 4 power k plus 6k minus 10 is divisible by 18. That's how we do prove by induction. First you need to prove it for the basic values 1 or 2. Usually 1, in this case it's 2. And then we need to assume that it's true. The statement is already true for k. And then we need to prove the statement for k plus 1. For n is equal to k plus 1, f of k plus 1 is 4 power k plus 1, 6 times k plus 1 minus 10. Subtract f of k both sides, because that's how we prove this divisibility, right? So it's 4 power k plus 1 minus 4 power k, 6 times k plus 1 minus 6k, minus 10 plus 10. Because you need to write f of k minus of f of minus k. So this can be cancelled, right? So what we are going to do, we are going to write this expression in terms of f of k. In terms of f of k. So we can say that if f of k is divisible by 18, whatever you are writing in terms of f of k, like multiplication of f of k is also divisible by 18. Okay. So I bring this f of k here. Now what I'm going to do, I'm going to simplify this. This is basically 4 times 4 power k minus 4 power k, which is 3 times 4 power k, right? 6k and 6k will be cancelled, so you will get only 6 here. 6k plus 6 minus 6k, you will get just 6. Now bring the f of k to the other side, so you will get f of k plus 1 is equal to 3 times 4 power k plus 6 plus f of k, right? If we can write this also in terms of f of k, that's all. We can say it's not in terms of f of k, multiple of f of k, then we can say it's all divisible by 18. We know f of k is this, 4 power k plus 6k minus 10. So if we have 3 times 4 power k, we need to have 3 times 6k also, right? And then we need to have 3 times minus 10 also. So I'm going to write this first. So we have 3 times 4 power k here. 3 times 6k is 18k, so I'm going to put minus 18k, so it will be cancelled. 3 times minus 13, sorry, 3 times minus 10 is minus 13. I'm going to put plus 13, so it will be cancelled, and that is 6 also here, plus 6 plus f of k. You see what I'm trying to do here? I have written this whole thing as a multiple of f of k plus or minus some extra terms, right? So this is 3f of k plus f of k is 4f of k, and then minus 18k plus 36. This is divisible by 36 is divisible by 18, this also divisible by 18, this also divisible by 18, right? So you just need to write the conclusion. First you write, therefore f of k plus 1 is divisible by 18. So you need to write, it's true, the statement is true, is true for n is equal to 2, and if it's true for n is equal to k, then it's true for k plus 1. N is equal to k plus 1. Hence proved. That's all.